Welcome to the Vitality Equation, exploring research in health and well-being one paper at a time. Today, we're diving into some fascinating stuff. I've been looking at this paper about using nanotechnology to boost crop resilience, especially focusing on plant-microbe interactions and how that impacts sustainable agriculture. It's a mouthful, I know.
That does sound like a dense read, but agriculture is key. So what angle are we taking today? Is it more on the nanotechnology or the sustainability side?
Yeah, and is it all theoretical, or are there actual real-world applications we can sink our teeth into?
Great questions. It's a bit of both, actually. The paper explores how nanotechnology, think tiny targeted interventions at the cellular level, can help crops better withstand the stresses of climate change like drought or extreme temperatures. And the real kicker is how it leverages the existing relationship between plants and the microbes in the soil.
Okay, I'm picturing something like tiny delivery trucks dropping off fertilizer right where it's needed.
Or maybe some kind of nanoshield protecting the plants from diseases?
Exactly. Those are great analogies. Think of it as precision agriculture, but on a scale we couldn't even dream of a few years ago. We're talking about things like nanosensors that can detect stress signals in plants way before we can see any visible symptoms, and then trigger the release of specific nutrients or protective compounds.
Wow, so it's almost like giving the plants a super-powered immune system? But how does the microbe interaction play into it? I thought they were all about bacteria that can make plants stronger.
Yeah, that's where it gets really interesting. The soil microbiome is this incredibly complex ecosystem. Plants and microbes are constantly communicating, exchanging nutrients and signals. Nanotechnology can be used to enhance these natural interactions. For instance, you could use nanoparticles to deliver specific signaling molecules that encourage beneficial microbes to colonize the plant roots.
Precisely. It's like amplifying the plant's own communication system. The plant calls out for help, and the nanoparticles make sure the right microbes hear the call and respond appropriately. This helps the plant access nutrients, resist diseases, and tolerate stress more effectively.
Okay, so the nano stuff is less about directly fixing the problem and more about optimizing existing biological processes. That's actually really smart. It works with nature instead of against it.
And it's probably more sustainable in the long run, right? Because you're not just dumping chemicals into the environment, you're encouraging natural resilience.
That's the hope, definitely. The goal is to create more resilient agricultural systems that require less synthetic fertilizers and pesticides. This would be a huge win for the environment, for human health, and for the long-term sustainability of our food supply.
But what about the potential risks? I mean, we're talking about introducing nanoparticles into the environment. How do we know they won't have unintended consequences?
That's a valid concern. We need to be really careful about the types of nanoparticles we use and how they're released. Biodegradability is key. We don't want them accumulating in the soil or entering the food chain.
Absolutely. The research needs to be very rigorous. We need to assess the potential toxicity of nanoparticles to plants, microbes, and other organisms in the soil. We also need to study their fate and transport in the environment to make sure they're not causing any harm.
It sounds like a really promising field, but there's a lot of work to be done to ensure it's safe and sustainable. So what kind of crops are we talking about here? Is this just for big industrial farms, or could it benefit smaller farmers too?
That's a crucial question. If this technology is going to make a real difference, it needs to be accessible and affordable for farmers of all scales, especially in developing countries where climate change is already having a devastating impact.
The paper doesn't focus on specific crops, but the principles could be applied to a wide range of agricultural systems. I'm thinking about the paper from last week, about how the Zambian farmers are using farmer-to-farmer education to improve pigeon pea cultivation. It made me think, could nanotechnology be integrated into those programs?
That's an interesting connection. You mean, could those farmers benefit from nano-enabled solutions to help them grow more resilient pigeon peas?
It's possible. Think about it. Pigeon peas are already a drought-tolerant crop, but maybe nanotechnology could enhance that resilience even further. Or perhaps nanosensors could help farmers detect diseases early on, before they decimate their yields.
Exactly. Imagine providing those farmers with nano-fertilizers that are specifically designed to release nutrients slowly and efficiently, minimizing waste and maximizing uptake by the plants. It could be a game changer for their yields and their livelihoods.
But it also raises some ethical considerations. We need to make sure these technologies are developed and deployed in a way that benefits the farmers, not exploits them. They should have a say in how these technologies are used, and they should receive fair compensation for their crops.
And we need to make sure the technologies are appropriate for their specific context. What works in a lab in the US might not work in a small farm in Zambia. We need to adapt the technologies to the local conditions and the farmer's needs.
You're both right. This isn't just about technology, it's about social justice and equity. We need to ensure that these advancements benefit everyone, not just a select few. On a personal note, this makes me think of how even my small attempts at mindfulness could potentially feed into solutions. I mean, it seems crazy, but if more people focused on being present, then problems can be identified earlier, right?
Well, in terms of cognition, you could look at CBT approaches that help with identifying triggers around stress for farming and that sort of work. So maybe farmer-to-farmer education includes CBT techniques to alleviate stress and improve the quality of the work.
Absolutely. And you can't underestimate the importance of physical well-being in all of this. I was just thinking about how mindful movement or simple breathing exercises could be incorporated into farmer training programs to enhance their overall resilience.
That's a great point. It's all interconnected. Healthy farmers are more productive farmers, and a healthy environment leads to healthier crops and healthier people.
It really is a complex system, and it's fascinating to see how nanotechnology could potentially play a role in making it more sustainable and resilient. What's your take on future research directions?
From my perspective, I'd like to see more research on the ethical and social implications of using nanotechnology in agriculture. We need to understand how these technologies will impact farmers' livelihoods, their access to resources, and their overall well-being. We also need to develop clear regulations and guidelines to ensure that these technologies are used responsibly and sustainably.
Yeah, and from a cognitive perspective, I think we need to delve deeper into how psychological resilience can be fostered in farmers. Understanding the cognitive processes that influence their decision-making, especially in the face of climate-related challenges, is crucial. We can then tailor CBT interventions to help them cope with stress and adapt to changing conditions.
And from a physical health perspective, I'd love to see more research on the impact of agricultural work on farmers' health and well-being. How do different farming practices affect their physical activity levels, their sleep patterns, and their overall nutritional status? Can we develop interventions that promote healthier lifestyles for farmers, improving their physical resilience and their ability to adapt to climate change?
Those are all excellent points. It's clear that we need a multidisciplinary approach to tackle the challenges of climate change in agriculture. We need to combine the power of nanotechnology with the wisdom of traditional farming practices, the insights of cognitive behavioral therapy, and the knowledge of nutrition and exercise science to create truly sustainable and resilient agricultural systems.
Absolutely. It's not just about technology, it's about people and the planet. And that's what makes this field so exciting and so important.
Agreed. It's a complex puzzle, but it's a puzzle worth solving. The future of our food supply depends on it.
Well, that's all the time we have for today. Thanks for joining us on the Vitality Equation. We hope you found this discussion informative and inspiring. Until next time, stay curious and stay healthy.
And remember to cultivate your own resilience, both inside and out.
Get your sleep.
Bye for now.